Sometimes one of the troubles that beginning math students have is they don't know what to do when they see a certain situation. So first off, we're going to distinguish between equations and expressions. In our book, it says the directions for expressions usually require you to simplify the expression. A simplified expression has fewer terms and is shorter than the original. So 6h plus 5i minus 4h can be simplified to 2h plus 5i. An equation has an equal sign in it. You see the word equal equation. When you solve an equation or find a solution, that means you find an answer. In this case, it will be in the form h equals 1. So, the first thing that we have to do is tell whether the things that we're looking at are expressions or equations. Number 1 is an expression because there's no equal sign in it. Number 2 is an equation. You see the equal sign right here. Number 3 is also an equation. You see the equal sign right here. Number 4 is an expression. There's no equal sign anyplace. Number 5 is an equation. You see the equal sign right here. Well, once you know whether you have an expression or an equation, it's important to know, what do I do next? Well, when you look at your equations, one of the things you can do is to check a solution of equations. So let's look at this first one here. Oops. Let's look at this first one and see if we can substitute to find the correct value. A, instead of writing A, we're going to write 7. Instead of writing B, we're going to write 1. So negative 7 plus 6, oops, that's a 6, times 1. Negative 7 plus 6 is negative 1. Next one, x is 2, so we're going to substitute that in here. Y is 1, so negative 2 minus 5 times 1, this is negative 2, minus 5 more is negative 7. Next ones. Okay, so 4 is A, B is 3, in the first case though B is cubed, minus 5 times A. It's time to get out our calculator, and so we would, on our calculator, 4 times 3 to the third. Make sure you go over 1, subtract 5 times 4, and we get 88. For the next one, negative 6 times negative 1 times 3 cubed minus 5 times negative 1. Okay, so it's time to take out the calculator again. I got to move this over a little bit. There we go. All right, so negative 6 times negative 1 times 3 to the third, arrow over 1, minus 5 times negative 1. And we get 255. Somebody made a mistake there. Oh, I know what I did wrong. Let's try it again. I didn't clear my calculator. Negative 6 times negative 1 times 3 to the third minus 5 times negative 1 gives us 167. Next one. Substitute again. Oops. A is negative 1. Minus B times, minus, I gotta switch that, minus B to the third minus 2 times negative 7. Now, it's important when you do this problem that you distinguish, because it's not saying 1 is cubed, it's saying negative 1 is cubed. So it's negative 8, negative 8 times, parentheses, negative 1 to the third minus 1 to the third minus 2 times negative 7 is 21. The last section that we have to do is solving equations. We're going to use the addition property to solve the equations. And I would suggest at first, although I do it all the time, is write the problems exactly the way that I do so that you make sure you get it correct. X plus 10 equals negative 9. We want to get the x all alone. To do so, we're going to have to subtract 10, but we have to do it from each side. These eliminate each other, and so we're left with x equals negative 19, which is the answer that we have there. I'm going to switch colors. Let's look at the second one. W plus 5 equals negative 2. Once again, we want the w all alone. To do that, we're going to have to subtract 5 from each side. Why? So that the 5's cancel. Notice in both cases, all I did is I just switched the sign for whatever they had with the number that was on the same side as the letter. All right, so we have w equals negative 7. For the last one, it looks a little bit different. I'm going to switch colors one more time. Negative 3 equals x minus 7. Once again, we want x to be all alone, but if you notice, x is on the right side. That doesn't change anything. We're going to add 7 to each side, and we get x, these cancel, equals 4. Or we would just write x equals 4 if we were writing it the other way around. 4 equals x and x equals 4 are the exact same thing. Two more problems for us to solve. Let's look at these two. We want the r all alone in the first case, so we would write negative 8 plus r equals 10. Add 8 to each side, and the 8's cancel, and we're left with r equals 18. Last one, negative 9 equals 9 plus v. We want the v all alone, and so we're going to have to subtract 9 from each side. The 9's cancel, and we get v equals negative 18. So we're doing just a little bit of algebra here in using the addition property in section 2.2.